Hello everyone. In this video we are going to solve this question 2. In this question 2 we are in the following situation. We have a response variable y that we want to predict, and we have a predictor variable x, which in this case is one-dimensional. And for x and y we have this joint distribution. Assume that maybe you had data and you use that data to estimate this joint distribution. For example, the probability that y and x are both equal to 3, you have to check the column x is 3, the row y is 3, you find that that probability is 0.06. And then you see here this 0.37, for example, is the probability that x is 3. And this 0.34 is the probability that y is 2. And of course, if you sum all the probabilities, you find 1. What we need is the prediction f hat when the predictor variable takes the value x, where now x is equal to 2. So we want to predict the response for a predictor variable x is equal to 2. And we know from our optimization problem that the best predictor is the conditional mean. So what we need to do is we need to determine the conditional mean expectation y given x is equal to 2. Alright, let us recall what are conditional probabilities. Assume we have the probability that y, the response, is equal to some value y given x is equal to 2, because we assume that we know our predictor variable is equal to 2. Then basic probability tells us that this probability is equal to the probability that y is equal to the value y and x is equal to 2, so a joint probability divided by the marginal probability x is equal to 2. For our case, we already know this probability. It's equal to 0.49. So we have to think on these joint probabilities and writing them as an expectation. If we write the expectation of y given x is 2, an expectation in a discrete setting is always equal to the sum over all the possible values of y. We take the value y, the possible outcome, times the probability that my response y is equal to y in a conditional sense. So this is the expectation we calculate. What are the possible values for y? Well, y can be equal to 0, 1.5, 2, 3, and 5. So we get here a sum y is in the set 1.5, 2, it's 3, or it's 5. What is in the sum? In the sum we have y, and then we write that conditional probability using this expression, and we get the probability y is equal to y and x is equal to 2. It's a joint probability divided by the probability that x is equal to 2. Alright, so now have a look. This probability here does not depend on the summation. So we can write this as 1 over the probability x is equal to 2. And now let's explicitly write that summation. We have y is equal to 1.5 times the probability y is equal to 1.5 and x is equal to 2. Plus the next possible value for y is 2 times the probability y is equal to 2 and x is equal to 2. And we continue like that also for 3 and 5. We can find all the probabilities in this formula here in the table. So if we fill in the probabilities, we get the following expression. And if you calculate this, you find the value 3.255. So if we know that the predictor variable is equal to 2, so given x is 2, then our best estimate f hat x is equal to 3.255.